All right, so I'm going to try something that might be a little experimental. We're going to jump through a couple commits as we go along, but at first I'm just going to start out with some slides. So I presented last Chippy about Pyweek 24, how it was coming up, and I showed you guys what I built for Pyweek 23. And so this time I did it with a team. So Tony, Sun, Edward Wong, they work with me full-time, and then Steph is right here. She was our graphic designer, and you'll see that she does spectacular work. And then Nathan's here as well, and he was joining our group, learning some stuff, and also contributed some great code. So the theme was, it ended up being "They're behind everything," and then that's the GitHub repo, just in case anybody has. Do they have Git for phones? I don't think so. You can clone it right on your phone and play it, but probably not. Anyways, they're behind everything. This is a maze that we played with in the game. And then this was kind of a screenshot that just showed the basic sprite and one of the designs that we ended up using. So we got a bronze for innovation, team innovation. And I think we could have done a little better, but it's a good place to start, right? So thank you. So this is competition brainstorming, right? Pre-competition brainstorming. We just had a couple brainstorming groups really quick just to try to get some ideas out, things that we might need to do, put together. And we actually ended up starting a little later than some of the other groups probably because we started on Monday, competition started Sunday. Once we started rolling by like mid-Tuesday, Wednesday, but we did have some stuff coming forward before then, but that's when we really started getting things together. So I'm used to a mouse, and I'm using a trackpad. So here we go. So what is it? In our game, Pyweek is a one-week contest where you create a game, right? So in our game, the theme was that Tony falls asleep in class, is stuck in a dream. During our brainstorming, we actually just wrote a random integer selection because we had a couple different themes, a couple different names, and then we picked one of a couple. So that's how the theme got chosen. And it ended up being an escape from room style game with mini games behind objects. We had to make some decisions about exactly what we could include and what we couldn't include based on time and difficulty. So it was kind of just jump forward with stuff. Let's see what sticks, right? So our goals: integrate everybody's work as much as possible. If somebody produced something and they said, hey, it might be good here, we try to integrate it. But we also had to communicate about, we need this, we need that, what's going to happen next. So I'm going to show you guys what happens along the ways. I included a couple quotes from the Tao Te Ching. So this one is, the master is ready to use all situations and doesn't waste anything. I thought that emphasized what we needed to do here. We had a week. We didn't know exactly what was going to happen, so we just threw it together, and we took advantage of that. So why would we do this, right? I think that there's a good chance to improve the workflow of your team by just experimenting under time constraints, right? We just throw something together, and we see what kind of new workflows evolve. Normally, we have issue tracking, and we do a lot of different things to guarantee that our code is right, documentation, testing. That stuff was thrown away. So it was just write code. Make it work in a week, doesn't matter in the long run, right? So we had a couple additional team members. That helped too. And we wanted to build new working software just to demonstrate what we could do. So this is my personal opinion. There's no substitute for competition, right? In wrestling, our coach would always say, get as many matches as you can in. So even though you go into practice all the time, you want to get a lot of matches. You want to compete. You want to go and try to get something working fast, and you want to do that as much as possible because over the long run, it's going to make you a better programmer, I think. So the master leads by weakening people's ambition and toughening their resolve. How? We're going to use Python. Just get stuff done, make it run. We want to commit and push, and then pull requests, merge, repeat, just as fast as we can, right? There's times when somebody would say, hey, I don't have this working, and I said, well, are you breaking anything? And they're like, well, no. Okay, then merge it so I know not to write the same stuff, well, not merge it. Do a pull request really quick, and then somebody else will merge it, right? But obviously, when you're working like this and you're talking to somebody about what they're doing, you get a lot more information if they commit it. So what we're trying to do is get people to commit it right away, put it into our master branch. So this is just a thought. We'll be filing for technical bankruptcy upon completion, right? Technical debt, I always think that's kind of a funny term because you could just throw your code away. All code is an asset, right? Well, some code is a liability. But that being said, just don't run it if you know it's a liability, right? So this is a quote. The master doesn't talk, he acts. So let's go to some code review. And now, in terms of this, I'm going to ask that if you have any questions along the way, please bring them up. I'm going to show you the game and then try to review some of the code. And there's so much code that you might be like, I can't follow you. And then we'll try to pick apart a couple pieces and show you what we can. So let's go to the first run. So we should be in master. And then with the game, you just do run game. So Python run game.py. So this is master. So this is our main screen. And then we got some great music, thanks to Nathan, and awesome animations with stuff. So, and then this was the general idea of the game. So, and then the basic game. You're in a maze, right? And you end up in mini games. This one, you got to go lowest to highest, past. And then this was just, we kind of wanted a couple different objects. So as Tony, you have to do your homework. The goal is to do your homework to escape this dream. So normally you would get a pin here. If you don't do your homework, you can't get the pin. So you got to make sure you do all your homework. And then here we go. Red, that's true. Green, that's false. Passed. Oh. So here we go now, 1872. Here we go, 1872. All right. So this, I ended up doing something that blocked this little stuff, but it was like last second trying to make some changes. And then this was the only one that blocked. So I was like, all right, well, we had to turn the game in. Otherwise, we would have taken care of this little bug that got blocked at the end. What's that? The punchline was, they play the bowl game tonight. Right? The rats are playing games in his dream. The doctor offers him medication, but he can't take it because they're going to play the bowl game. Right? So it was good. There are lots of great jokes. I talked to Nathan. I was like, yeah, we need some topics, something like that. And then we got some really great stuff put together. So yeah, I'll make a couple slight changes here just to kind of show you what's going on. So let's go to the constants, right? So determining how to actually make this map, how big to make it, and what to do with it. Bigger code, got it. How big to make it and what to do with it was a matter of how to play the game. Do you want to be able to see the whole map or not, right? So if we take a look at the game with an adjusted game size, and I'll skip the intro for a second. You can see that it's a maze. So, and the maze actually was code generated from the source of all knowledge, which is Wikipedia. So Wikipedia had, at one point, we were getting pretty late in the competition, and what are we going to do for levels? So maze generating algorithms, right? Wikipedia. Just jump right on it, grab that code, and then add in a couple lines here with the maze algo. Add in a couple lines. This is the main code, right? So this is the main code, the chunk from Wikipedia. And then add in a couple lines that generates multiple levels and then figures out whether the levels have more than 6 corners. And if they have less than 6 corners, generate another level, because the corners are being used for the 5 locations of the items and the player. Question?
So does that mean each time someone plays the game, it's a different maze?
There's 70 mazes. We could have run this actual code in the game, but it just seemed easier to say, like, hey, let's just generate the maze now, because what if we were trying to get the corners and then the corners ended up, okay, make another maze in the middle of the game. So there's 70 levels, but there's only 8 that you actually play. So it's the levels.py file looks like this. It's true, false, 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 false. So, and then you end up with corners at the bottom of it, the corner dictionary, and those end up getting popped off and set as a location for the different characters. So we can try this with a different level. We can try it with level. All right, I'm going to get rid of this levels file because it's making me dizzy. We can try it with level. Let's try it with level 70. And then you'll see the most complex level. So you saw the simplest one, level number 70, right? This is the most complex level. So running this code, we're going to, I meant to skip the intro. When I was debugging, I would always just skip the intro, and then I'd have to remember before we do the pull request to put it back on, because otherwise you're going to be like, hey, this awesome intro, it's not there anymore. What'd you do? So, but debugging, for debugging reasons, when you're doing the levels, you want to save about 10 seconds as you're running the code back and forth. So this is the final level, and as you can tell, it's a pretty significant maze. So that's here. So up here, let's zoom out just a little bit. So up here we have the game window, and here's where we go into the intro. So if we jump straight to the game, we'll get to see that right away. And then if we jump to a little bit of a smaller map, we get to see the mazes. This is the maze. This should go straight to the game, right? So this is the final, the biggest level. And I can't even figure out where I'm hiding. Oh, there I am. And I'm in a corner. I'm in a corner right, where is it? Right here. But yeah, so that being said, I think we can stash all these changes. Let's just stash these, throw these in a stash, and oh, there we go. Stash them all, and then we'll check out another branch. So let's start with the beginning one. We'll do a git checkout of, this is the first branch. So this is where we started from. Run game. So this is what we had, right? I know it doesn't look like much, but this is the beginning of something great, right? So we're working from a little guy, and his controls are up, down, left, right. Left goes left, up goes down, left, right, and we got a shelf. We got a shelf, right? So we got something that was really good. If you take a look at the code, it's just all shoved in main. It's just one chunk, right? Like our guys were learning on the fly. What's up?
Yeah,
question.
Quick question. So
Yep.
I see that you had a order of nested for loops.
Uh-huh.
So I realized that you probably accumulated a lot of that as you were creating this.
A lot of what?
That as you were creating this. So how does Pygame? Do you ever see
You mean like a slowdown?
Yeah.
I have never, and it's kind of amazing because you think like, hey, we're doing tons of stuff here, right? We're getting a screen, displaying the mode, and then we're blitting it, and it's occurring every like 3 milliseconds. It should be occurring like 60 times a second, right?
Yeah,
How's it going, Michael?
Slow down, but did anything show up in the game that was unexpected that you kept in there because you thought it was kind of cool?
There was a couple things that showed up. More often than not, we didn't try to keep them because they weren't kind of cool, right? So if there was something that was really cool, I would have said, totally, let's keep this. But a lot of times it was, hey, I'm stuck in a wall, right? I don't really want to be stuck in a wall right now, and now I need to stop the game and restart it. So, yeah. And you'd think there's so much going on at once that how can the system go this fast? But man, computers are fast. Like it's amazing. That maze generating algo code generates 70 mazes with all the corners in like a quarter of a second or something like that. It's incredibly fast. So yeah, I mean, I would say just try to break it, right? Just try to break it. If you can't break it, then you're good. And if you can break it, then let everybody know, right? So we're going to jump over to the next commit now. And I'll try to be fast with these commits because when you're going through commits, there's millions, right? So I think we ended up having something like 265 commits and 64 branches or something. So this one, now we don't have any music. We ended up using a GIF at first, right? So we were using a GIF to do this front end, and then we talked about it, and potentially it was a lot easier to do it as pictures and a lot cleaner. So we ended up doing it as JPEGs over and over, and just iterating through all of them. So there's like 150 JPEGs that it's going through in the future versions. But the start button works. Now the movement's a little different. I talked to somebody about potentially making the movement a little bit different. If you press left, you turn a quarter angle to your left, right? Or maybe it's an eighth, but you turn 45 degrees, right? You turn 45 degrees to your left. Same thing with right. So this little character, he looks very happy, right? So so if we look at the code, it's very similar to what it was before. But now it's in a game section, and now the character is separated from the game, right? And then the game is starting to expose the intro and trying to pull things together, right? We don't have any levels. No levels, just, hey, we got something launched. We're making this more object-oriented. We're separating some of the pieces, right? So even here, essentially, we just took the code from the main file and just plastered it in here, right? And then added an intro, added a game window, and took some of that architecture from some of the other games that we saw. Like how do you make this separated in each object so that people can work on different aspects of the code, right? We have 5 people working, 4 of them are working on code. One's working on graphic design. We have to communicate over, you do this, I'll work on that. Question?
When the game is being evaluated at the end of the week, do they look at the code and,
No, not at all. Nobody cares about the code. So you could get the difference between a 3 and a 4 could be completely just based off like some shiny object or some fact that somebody like got stuck in your game and hated it. And but yeah, I mean, they don't look at the code. But one of the advantages of the code and something that I noticed as we were going along was that when you write the code correctly and very abstract in a good, clean way, it's much faster to develop, right? So.
To add a point to that, if you can't run it, then they'll disqualify you. Like people will vote to, it like doesn't work or something.
Yeah, they'll vote it doesn't work.
So if you have a bunch of dependencies that like they have a hard time compiling something with GCC or something like that, then they'll vote you down for it.
But surprisingly, I don't know if there's a way I can connect right now. Is this? This should connect me. But surprisingly, the game that had the highest score was.
Yes, man, I got the pass.
Okay. The game that had the highest score is that. Am I connected or not? Totally not. Oh. Okay. It's right behind me. Got it. 3, 3, and 606. 2, 606, 02. Yeah, that's right. Okay. One of the games that won was, and I'm kind of jumping off course a little bit, but one of the games that won this week, entries, rankings. Here we go. If you look at this game, the Larry and Dan show, and I tried to run this, 41% of people said it didn't work, and they won. So 7, I think they had 7 reviews. I tried to run it, and I was like, this, it didn't run for some reason. It had this weird, really strange dependency. So let's jump to the next commit, since. My sincerest apologies. I think they did that on purpose. Maybe it was like a joke, and I don't know, but apparently it was good. Whoever played it, it kind of makes you like sad, like, hey, I wish I could have played that, right? So yeah, we'll jump to another commit. Let's see what we got. Let's see, commit number 385. 385, okay. And this is, we add a lot of sprites, animations. We end up transitioning the video or the animation into like a full video. The screen's modified, and we get the basic architecture for the levels and the states, and the character movement's made continuous. Oh, I checked it out again. Same thing. All right, so that's our intro, right? Boom. Now we're starting to get somewhere, right? Except our character still is living in a world where nothing happens, essentially. So now you click on here, 2407. You know, you need something just to fill the space, right? The thing about this one is it goes on, like initially when we created that, I don't even think you have to get them all right. I think I just kept pressing, and then I was like passed. I was like, wow, I wish school was this easy, right? So yeah, that was the beginning. But the idea is, hey, this is starting to pick up. We're starting to get things in place, right? So let's jump to this is pull request 54. I'm going to jump to, and if I show you the code, I'll show you really quick because it's pretty much the same stuff, except now we have an empty shell of, or a little bit of a level, but we didn't actually use this at all. We were trying to use what's called TMX, and it's from a tiled editor, but it's incredibly frustrating. So we just skipped right over it, and we went straight to that levels scenario with just a list of lists with true and falses. So we'll go to check out 1.8. There we go. Let's check out this one and run it. Boom. So same thing, animation's looking pretty decent. So start it up. Now we have a different background, right? And this guy moves a little faster, but that was just a setting. This one, now we have game animation. We still are using that filler for the number. And then for this, we have our sequence game too. So we have the basics of our mini game. Now we have ending animation. I know I didn't show you guys this originally, but it's pretty awesome. So Steph did a great job with that. This eventually gets updated, and then there's a win and a loss animation too. So yeah, these things are starting to come together. And then we move forward. We'll jump forward a little bit. Go to commit 60, or this is pull request 61. So, and really quickly, we can take a look at some of the code. So almost everything's coming from the game now, right? A lot of stuff's in the game, and then stuff is in character. The character has all this animation, right? So really quickly on the animation, even though the game seems really simple, it's one level, blank screen, this animation is set up now. Now we got this, we can put it behind us, we can just let it go. There's a dictionary saying what direction we're pointing, and then another dictionary saying which part of the animation that we're in, which step of it. So the move action dictionary ends up getting picked from the direction dictionary. So using that direction dictionary gives us what image we're taking, and then using that, we end up updating the image. So right here, we go through our update. It's just telling us where to move. This update function in the final look, this update function ends up being a lot more complicated. And part of that is because you can use update to help the sprite interact with objects, to help the sprite interact with other sprites. So we'll jump forward a little bit. I thought originally when I showed this presentation to someone, I thought, well, it's a little confusing if I show you, we check out a branch, or check out a commit log, and then you're taking a look at it, and then all of a sudden all the code changes, right? And then you're like, I remember this variable being there, but it's not there anymore. So you kind of have to like wipe your mind clean and think like, well, that might not be there anymore, right? So we're going to jump forward. This is number 60, pull request 61. So this is right near the end. Here we go. We can still start, boom. And so now we end up with a level with some different colors that we just pulled up, and we have a pin, and it looks like almost like our final game, right? 2794. So I'm going to remember that pin number, but the thing is, it actually doesn't matter at all because at this point, the pin is just hard-coded in, and the answer is 1, 2, 3, 4. So if you put 1, 2, 3, 4 in, 3, 4, you win the game. So now you win. 1, 2, 3, 4. But the important part was that we know it works, right? We know we got there. We got somewhere. So we're moving along. And now, because we created a whole level, all we have to do is do that 8 more times, right? So it's not 8 more times the work. It's, 0.0001 times the work, right? So we're doing just a little more work, or I should say 1.001, right? Otherwise we have to do less work. So yeah, it ends up being just very little more work to add that in, right? And then there was a whole bunch of bugs that we'll just pretend don't exist, right? So let's check out master. Boom. So we went through this, right? Just want to put you guys back in perspective of where we came along, right? Now, realistically, it's more difficult to play like this. You don't get to see the whole map, but then as the game goes along, you get more lost. So getting to this point was pretty rough, and then I was doing a lot of the stuff right then, trying to say, well, what fine tuning can we do, right? What kind of fine tuning can we do? So actually, the last day of this event was my birthday, so my family was over and my niece was over, and she's 8, so I had her play it. I was like, you're my tester, right? You're my play tester. Tell me everything that's wrong with it, and then most of the things that were wrong with it, I didn't have time to fix anyways. So I was like, well, I guess that's going to be confusing, right? One of the things that was really frustrating was in the mini games, there's not enough feedback. People play them, and then they click on a button, and nothing happens with the sequences, right? You have to click the 4 sequences in a row. We'd be a lot better off if the number disappeared, right? If it was an active button. So, but she liked it, and that was what was important. She was playing it, and she was like, I want to play again. I want to play again. And I thought it was kind of nice because you can't really lose this game. The only way you can lose is if you put the wrong pin in 3 times in a row, which means if you saw the pin and you put the wrong pin in 3 times in a row, you forgot the pin, right? So that gives me a chance to jump right in to the next section, I think. And we can take a quick look at the code at the end of this. But the next section is reviews, right? So the first review, my favorite, because this was the highest score we got. And it says, not sure why I lost at the end, nor could I figure out how I was doing, well or bad. And I'm not sure what I had to do with, to win. So I kind of like snickered. I was like, well, you put in the wrong code 3 times, right? Which makes me think, like, if you put it wrong in the first time, like, maybe you didn't remember it well. Like, you can always go back and check it out. But anyways, I think the losing scene's like just as cool as the winning scene, except it's a little more depressing. So the idea was fun and funny jokes, although passing the same test again and again got a bit annoying. They get a little tougher down the line. They're not too tough, so I could see where that opinion comes from, right? It would be great to have some visual feedback after clicking something. Totally agree. I had fun figuring out the mechanics. I like the puzzle. So the mechanics were a little complicated, where you press left, you turn a 1/4 degree left, you press it again, you turn another 1/4. But when you think about it, it actually makes more sense because you always walk the way you're facing pretty much, right? So you turn first and then you go. And once you get used to it, it's pretty comfortable actually. But I can see why somebody didn't like it. I played with it for a while and it's difficult for about the first 15 minutes. So intro sequence was great. Maze part of the game had odd controls, mishmash of isometric sprites and top-down collisions. Puzzles were dull and basic, right? So this was the worst review we had. And I'm going to give them credit and say that they actually realized we were trying to do isometric stuff. We were trying to. We were like, hey, we're gonna get isometric setup. So we built out the sprite, we built out the animation, the motion, all that stuff, and we were working really hard trying to figure out how the mapping system could work. Maybe there could be isometric, and it was more research than development, and so it became an issue of let's just get something working, right? But it would have been super cool to make it a maze and make it isometric and just change the angle of everything. You know, it seems like it should be easy. Yes?
As I hear you talk about this, it sounds like, well, we did it and that's it, but why couldn't you just keep working on it?
Well, we can. I mean, we can keep working on it. The question is, like, what do you benefit from it at a certain point, right? And we talked about it, like trying to make it into like something that could go mobile, and then at least people would be like, hey, boom, set this up, right? And then when you do mobile, do you have to press something and have the guy automatically move, the sprite automatically move? So there's a lot of details that would say, hey, we could keep working on this. I mean, it's open source code. You guys could work on it too. If you do a pull request, I'll take a look at it, right? There's no reason. If you play the game and you say, hey, this could be a lot better. So I did include some pieces for what could improve this game, right? I think it's cool that you have 12 free testers, right? Obviously, it's like you have to give up your code, but you have 12 free testers who are actually going to give you reviews, and that's kind of difficult. At least in this competition, sometimes it's more. Sometimes it's way more. So fine-tune speeds, controls for immediate and intuitive movement. I think that we could have kept the controls the way they were. Press left, turn left, but you should also be able to hold left and turn left longer. We tried to set that up at first, but then it was too sensitive. And you'd turn 8 spaces left in a 1/4 second, and you'd be like, I didn't want to do that. So it was very hard to just turn one spot. So then we said, just press it once, turn it. Consider more concepts for mini games, difficulty tuning, better feedback. I think that the mini games are probably the most important thing behind this because it's the only real challenge, right? The maze is fun, but like you're essentially just burning time off, just searching around like, hey, there's like nothing's gonna happen, I'm not gonna lose, right? The mini games, you have to beat something, right? So if they're more difficult or if they're more fine-tuned to make sure they're difficult, and if they pull people in more and they provide feedback so people get excited about them, that I think is huge. So trying action within the game to keep the player stimulated during the maze, right? if there's some unexpected event that happens, then the player might want to be more involved. So, and then adding some type of storyline between levels. So after all the changes, we'd want to get additional review and some feedback. So here's one more quote: "Do your work, then step back. The only path to serenity." So I'm going to take any questions, and we'll take a quick look at the code if you guys have any questions revolving around like levels, characters, characters. So ultimately what happened was there's a game window, an intro, transitions, game, levels, and a character here, and then objects. And the mini games are in a file called state. So you can take a look at this anytime you want.
So I see you're switching a lot, a lot of like switch statements almost. You're switching states a bit. Have you ever thought about using a formalized pattern like finite state machines or something like that, where you have callbacks to actions?
Callbacks to actions. How so?
Like a state machine, when it alters from states, you can attach actions to them and things like that. But have you ever thought about using like a state machine diagram? There's a library called FSM, I think, for Python that would help.
We didn't think about actually using the library. I think the design choices bordered on it. We were like bordering on, returning different states that put us in a different location. So we made some design choices that were coming close to it, but we didn't actually talk about, hey, let's create this state machine. It was more so, let's create this object, enter the object, put some type of state going on in the object, exit the object, go back in the other object, and then create another object for another state, right? So all these objects end up jumping into their own loop, right? So the game has the game has a loop, and then inside that, the level jumps into a loop, and then the state jumps into a loop, and then you exit the state, and then with the state, you exit that, but you write back something to the level, which records that data, like you beat that mini game, right? And then that writes back to the game when you beat the level, and then it says you beat that level, next level. Make sense? Any other question? Oh.
Did you use delta time for the animations, like in the beginning and the end?
We used delta time overall, right? So what we did with it was we set a delta time in the game window. But ultimately, I think what we did with the time for the animations was we just used a raw time. So we used a raw time. This is the intro. So this is the animation, and most of our animations look the same way, right? This was very coordinated in terms of the naming system, right? There's an initial name, and then there's a number string, and then we go through all the sequences, right? This time, where do we get Pygames time.getTicks? It gets set in the last time, and then we get the ticks. This is basically telling you this is now, right? This is a way of saying like time.time, finding out now. Last time plus 20, 20 is 20 milliseconds. So in 20 milliseconds, we start the other animation. This was vital code for us because it let us do a lot of cool animations and stuff. It was also something we repeated ourselves on a couple times, where if we abstracted it more, there's an animation in the state, and then there's this animation and transitions and win-losses. So it was just something that we ended up jumping around for. So make sense? Any more? So right here, here's our game. This is where you enter the level, and then the level gets created, and there's a similar structure for the state. All right, great. Thank you very much.
Thanks.
Yep.
Awesome. We're going to take a stretch, a little break, and then we're going to have one more presentation tonight.